So range of each number system. Let's find out range, how many numbers we can represent. So let's start with 3 bits. Let's start with 3 bits. With 3 bits, tell me how many combinations are possible. If you have 3 bits, then how many combinations are possible for 3 bits? Total 8 combinations are there. Total 8 combinations are there. Okay. So we have total 8 combinations. Now let's write those 8 combinations. So let's assume that you have these 3 bits. Your 3 bits are like this: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so these are your 3 bits. Now these 3 bits, what they represent in, if they are unsigned. If they are unsigned, what they represent, and if they are signed, what they represent. If they are signed, what they represent. In signed, again, if they are in signed magnitude, what they represent. If they are in signed magnitude format, then what they represent. If they are in 1's complement format, then what they represent. And if they are in 2's complement format, then what they represent. Okay, so this is the idea. Now let's see. You can notice one thing, that unsigned, when they are unsigned, because if they are unsigned, then very simple, this will be 0, 1, 2, 3, 4, 5, 6, 7. If they are unsigned, there is no problem. Now if they are signed, if these numbers are signed, then you can notice that if the MSB is 0, then all these 3 systems are same. All these 3 systems are same if MSB is 0. If MSB is 0, then your number is positive and all these 3 systems are same. So all these 3 systems are same. So it will be, remember, this is the sign bit. This is the sign bit. Okay, so it will be like, I can say it will be 0. It will be 0, 1, 2, 3. Okay, it will be 0, 1, 2, 3. It will be 0, 1, 2, 3. Okay, there is no problem here, because you know that all these 3 systems, are same for positive numbers. If your number is positive, or I can say if your number is non-negative, then all these 3 systems are same. Okay, very simple. Now let's come back to these. Now here in the sign magnitude, this is minus, this is minus, this is minus, this is minus. So in sign magnitude, this is minus 0, this is minus 1, this is minus 2, this is minus 3. Okay, next, in 1's complement system, what are these values? 1's complement, these are negative numbers. All these are negative numbers. In 1's complement, what this will be? Take the 1's complement of this. Take the 1's complement of this, that will be 0, 1, 1. So that is 3. So it is actually minus 3. Take the 1's complement of this. Take the 1's complement of this. So that will be 0, 1, 0. So that is minus 2. Take the 1's complement of this. That will be 0, 0, 1. So that is minus 1. And okay, so this will be minus 0. Correct? Very simple. Because remember, if you have this number, like if I give you, see, take this number 1, 0, 1. Take this number. In 1's complement system. Okay, in 1's complement system, what is this? In 1's complement system, what is this? If I ask you, what is this value in 1's complement system? So in 1's complement system, this value will be negative, because this one implies negative. Okay, so this will be negative. Negative of, you take the 1's complement of this, so that will be 0, 1, 0. So that is minus 2. So in 1's complement system, this is minus 2. And in 2's complement system, what is this? In 2's complement system, what is this value? In 2's complement system, this is minus of, take the 2's complement of this, take the 2's complement, so that will be minus 3. So you can notice this 1, 0, 1, this 1, 0, 1, this is minus 3 here. This is minus 3 here. Okay, let's see what this 1, 0, 0 is. This is negative because of this one. Because of this one, this is negative. Now, okay, so you can use this 2's complement is a weighted code. Remember, this 2's complement, this is a weighted code. So this will be minus 4. Very simple. This is a weighted code. So this will be minus 4 plus 2. Minus 4 plus 2. So that is minus 2. This will be minus 4 plus 3. That will be minus 1. Okay. Did you get it? Did you get it? So, okay. Now, one important observation. There are 8 combinations. If there are 8 combinations, so what is ideal? What is ideal situation? What is ideally? These 8 combinations should represent 8 numbers. Yes or no? 3 bits. See, 3 bits 8 combinations are there. What is ideal? What is ideal? Ideal is that these 8 combinations should represent 8 quantities, should represent 8 quantities, 8 different quantities, or I can say they should represent 8 different numbers. They should represent 8 different numbers. But is it happening? Tell me, is it happening that, okay, that 8 combinations you have, are they representing 8 different numbers? So for example, yes, unsigned is representing 8 different numbers. So you can notice, okay, this ideal situation is working. This ideal situation is working for, this ideal situation is working for unsigned. Unsigned is unsigned, okay, is ideal. I can say all the 8 combinations, they are representing 8 different numbers. So in unsigned number, you can notice all these are different numbers. Similarly, in 2's complement, in 2's complement also this is happening. This is happening in 2's complement also. You can notice in 2's complement 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4. So 8 different numbers are represented. 8 different numbers. But can you notice how many different numbers are represented here? Tell me. How many different numbers are represented here? Okay, remember this and this. Please note this and this. Similarly, please note this and this. So you can notice that, okay, this sign magnitude and this 1's complement, they are representing only 7 different numbers. Okay, so you can notice that this sign magnitude system, and 1's complement system, okay, they basically they represent only 7 different values, only 7 different values, different numbers. And what is the reason? What is the reason for that? The reason is that they, okay, 2 combinations are used. See, 2 combinations are used for 0. 2 combinations are used for 0. The reason is 2 combinations are used for 0. 2 combinations are gone because of 0. Okay, so this is a note. This is a note. I can say that in in 1's complement and sign magnitude, you can notice. Let's see in sign magnitude what is happening. In sign magnitude what is happening, and in 1's complement what is happening. In 1's complement system what is happening. So tell me here, what are the representations of 0? This is also 0. This is also 0. There are 2 representations of 0 in sign magnitude. In sign magnitude, let's assume you have 4 bits. Okay, assume you have 4 bits, using 4 bits. Then using 4 bits, then what will be? Tell me what will be the answer. Using 4 bits in sign magnitude, this 0 and, okay, so this 0 and, okay, this is 0, 0, 0. This is 0, 0, 0. Correct? Both of them are basically 0. This is also 0. This is also 0. Both are basically 0. So for 0, you have 2 representations. In 1's complement, what are the 2 representations for 0? In 1's complement, what are the 2 representations for 0? What are those 2 representations for 0? So one is 0, 0, 0. This is one representation. Another is 1, 1, 1. Okay, another is this. Remember the difference, because you can notice this is also minus 0. This is a minus 0. Okay, so you can do this for n bits. What you will say for n bits? For n bits, you will say that the sign magnitude is basically, I can say it will be like 0, 0. And then you have all the, okay, all zeros. And here also you have, this will be 1. And here also you have all 0. So these 2 combinations. Okay, next, in 1's complement system, this 0 has 2 representations. This 0 has 2 representations in 1's complement system. Those 2 representations are like this. Okay, you have all zeros. This is your 0 in 1's complement system. In 1's complement system, this is 0. Also in 1's complement system, this is also 0. All 1's is also 0 and all 0 is also 0. Is this clear to everyone? Now let's come back to our point. So you can notice using 3-bit, there are 8 combinations possible, but you can notice that The 2's complement and unsigned. These are representing 8 different numbers, 8 combinations, 8 different numbers. But you can notice sign magnitude and 1's complement system. These two systems, they represent only 7 different numbers. And what the reason? The reason is that for 0 they have 2 representations. In sign magnitude for 0 these are the 2 representations. In 1's complement system for 0 these are the 2 representations. Similarly, you can notice in sign magnitude for 0 these are the 2 representations, and in 1's complement for 0 these are the 2 representations. And remember, in so also in 2's complement every number has a unique representation, correct? In 2's complement system, I can say in 2's complement system every number has a unique representation. Every number has unique representation, correct? Every number has unique representation. Okay, every number has a unique representation. Very simple. But this same statement we cannot say for 1's complement and 2's zero sign magnitude, because they have different representations for 0. For the same number they have different representation. For the same number they have different representation. Now let's find out the range. Okay, so now what is the range of sign magnitude? So what is that? Range of sign magnitude number system. So if you have using 3 bits, please tell me, using 3 bits, what is the range? What is the range of numbers this is representing? The sign magnitude. The sign magnitude, what is the range of numbers this is representing using 3 bits? So using 3 bits we have already seen. Using 3 bits, what is the range they will represent? What is the minimum they will represent and what is the maximum they will represent? Tell me, what is the minimum they will represent and what is the maximum you can represent? Maximum you can represent, maximum must be positive. Just think about it, please think about it. Maximum must be positive, so maximum should be like this. This should be the maximum and minimum should be this. So this should be the minimum and this should be the maximum. Now let's find out. So the maximum should be, I can say, now this is maximum is plus. Okay, you can put 1 1. This is the maximum you can create. This is the maximum number you can create. This is a positive, so I can say answer will be 3. Or I can say plus 3, because this is the maximum magnitude you can create. This is sign, and this is magnitude. This is magnitude. Okay, so the maximum magnitude you can create is 3. This is the maximum magnitude you can create, and this is the sign. So I can say maximum number you can represent is a plus 3, and minimum number you can represent this means minus. And minimum, I want to represent minimum number, then should I do this? Please tell me, should I do this? No, this will give me minus 0, but actually this will give me minus 3. This will give me minus 3. Okay, so this is the range I can represent. So using 3 bits, the range is minus 3 to plus 3. How many numbers? Range is minus 3 to plus 3. How many numbers in this range? Minus 3 to plus 3. How many range? So total 7 numbers. You can check it out. Total 7 numbers are represented. Using 3 bits, we are representing only 7 numbers we can represent. One is wasted. One combination is wasted, I can say. Okay, 7 numbers. So it simply means that one combination wasted. Correct or not? One combination wasted. Because total 8 combinations are there and you can represent only 7 numbers. It means one combination is actually wasted in this sign magnitude. Now tell me, what will happen for n bits? If you have n bits, then what will happen? Using n bits, what is the minimum you can create and what is the maximum you can create? Remember, maximum means it should be 0. Maximum means it should be 0. And minimum means it should be 1. Okay, negative. So what is the maximum value you can get? This is 0. All these you can put 1, 1, 1, 1. So how many 1, 1? N bits, total n bits you have. So how many 1, 1? Tell me how many ones you have here. How many ones you have here? N minus 1 ones you have. N minus 1 total ones you have here. N minus 1 ones. Okay, so that's the idea. So what is this number? N minus 1 ones. What is this number? This is 2 power n minus 1. 2 power n minus 1 minus 1. This is the number 2 power n minus 1 minus 1. Because you already know, I hope you already know that what is this number. If I ask you what is 2 power n, then that will be 1 followed by n zeros. 1 followed by n zeros. This will be 2 power n. For example, 2 power 4, 16. 2 power 4 is 16. That will be 1 followed by 4 zeros. Similarly, if I ask you what is 2 power n minus 1, it means total n ones. Total n ones. For example, if I ask you what is 7, 7 means 2 power 3 minus 1. So that will be 3 ones. So that will be 3 ones. Okay. If I ask you 15, 15 means 2 power 4 minus 1. That will be 4 ones. So you can notice 2 power n minus 1, 2 power n minus 1. That is your n ones. So finally, the answer will be, okay, the maximum you can create, that is 2 power n minus 1 minus 1. This is the maximum you can create. And the minimum you can create is the, okay, negative. Minimum you can create is negative. And here what you will do, again, you will put all the ones. This will give you the minimum. So the minimum you can create is negative of this 2 power n minus 1 minus 1. Remember, this simply means negative. This simply means negative, and this simply means positive. So here what you will get, this is the magnitude. Remember, this is the magnitude. Okay, this is the magnitude. So because these are n minus 1 ones, how many ones you have here? N minus 1 ones you have here. So that is the reason negative of 2 power n minus 1 minus 1. So what is the range? Finally, please tell me what is the range of this sign magnitude. Finally, what you can say, what is the range using n bits? Using n bits, what is the range you can say? The range will be minus of 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. Okay, I can say from this to plus this. So this will be the answer. Like example, using 6 bits, what will be the answer? Or I can say using 4 bits. Tell me, using 4 bits, what will be the answer? Using 4 bits, the answer will be minus of 2 power 4 minus 1. So that is 2 power 3. So that will be minus 7 to plus 7. Is it clear? Let me know. So very simple. So this is how you can find the range of sign magnitude. Now let's find out range of 1's complement. Range of 1's complement system. 1's complement representation, range of that. So let's find it out. So what this will be? So tell me here, what is the minimum you can represent? Again, use first, let's check it out using 3 bits. Let's do using 3 bits. So using 3 bits, what is the minimum you can put and what is the maximum you can put? Remember, minimum, maximum means it should be positive. Maximum means it should be positive. This 0 implies positive. Okay, and minimum should be starting with 1. This 1 implies negative. You already know. So tell me, the maximum you can put is plus 3. This will be the maximum number you can put. And what is the minimum you can put? Should I do this? Please tell me. Should I do this? Should I do this? Is this correct? This is not correct because actually this is minus 0. See, this is not correct because this is minus 0. This is correct. You can check it out. This is correct. And this will give you minus 3. Okay. So this will be minimum and this will be maximum. So this 1 0 0, this will give you minus 3. Remember, if you do 1 1 1, that will give you minus 0. That is not minimum. So this will be range. So the range using 3 bits, what is the range using 3 bits? That is minus 3 to plus 3. How many numbers? Minus 3 to plus 3. How many numbers? Total 7 numbers. Total 7 numbers. So one combination wasted. I can say one combination gone, or I can say one combination wasted. Clear? Very simple. Next. So the same thing, let's do using n bits. The same thing, let's do using n bits. So using n bits, what will be minimum you can represent and what is the maximum you can represent. For the maximum you will start with 0 and for minimum you will start with 1. So here what to put? If you want maximum, then here you will put all the ones. Total n minus 1 ones you have. So the maximum will be 2 power n minus 1 minus 1. This will be the maximum because total n minus 1 ones you have. Okay. Here, what this will be? This will be, you can check it out. Okay. To get minimum, don't put 1 1 1 1 because if you do this, it will be minus 0, which is not minimum. If you do this, it will be minus 0, which is not minimum. So you should do all the zeros. All the zeros you should do. So finally here, the value, if you check the value of this, if you check what is the value of this in 1's complement system, in 1's complement system, what is this value? Tell me. Tell me in 1's complement system, what is this value? In 1's complement system, if I ask you what is this value, then what that will be? That will be negative of, you find the 1's complement of this, negative of this, and that will be negative of 2 power, okay, all ones, basically all ones, that is 15. So that will be negative of, 2 power 4 minus 1. This will be the answer. So finally here also, what this represents negative of 2 power n minus 1. So the same range we are getting. What is the range we are getting? So finally, what is the range in 2's complement using n bits? If you have n bits, then what is the range you are getting? The range, same range you are getting, just like sign magnitude. The same range you will get from this to this. 2 power n minus 1 minus 1. Okay. So this is the range that you will get. Very simple. Now let's move on. The same thing, like, okay, you can take example. Let's take example. Like using 4 bits, what will be the range? Or I can say using 5 bits, what will be the range using 5 bits? The range of 1's complement representation. For this 1's complement representation, the range will be minus of, okay, 2 power 4 minus 1. So that is minus of 15 to plus of 15. Minus 15 to plus 15, this is the range using 5 bits. Let's see the next thing, that is 2's complement system range. What is the range of 2's complement system? The same thing we will do. Again, first we will find for 3 bits. Let's find for 3 bits. If you have 3 bits, then what is the minimum, what is the maximum you can create? Remember, 2's complement system is a weighted code. So use that concept. Okay, this is a weighted code. This is a weighted code, you already know. This is a weighted code. This is a weighted number system. You already know. Use that concept. So what is the minimum you can create and what is the maximum? Maximum is very simple. You start with 0. Now, all the ones you put here, all the ones, this will be the maximum. So maximum is same. Plus of 2 power n plus of, I can say, okay, for 3 bits we are finding. Okay. So for 3 bits we are finding, then this will be the number. And this number is basically plus 3. What is the minimum that you can create? What is the minimum? Remember, if you want minimum, then this is giving you minus 2 power 2. This is giving you minus 2 power 2. If you want minimum, don't add anything extra. So just put 0, 0. So this will give you minus 4. So the range is what? For 3 bits, what is the range for 3 bits? The range is minus 4 to plus 3. How many numbers? The range is minus 4 to plus 3. How many numbers? Total 8 numbers. Nothing is wasted. Because every number has a unique representation. For every number, you have a unique representation. So that is the reason nothing is wasted. And finally, I can say that 8 numbers you can represent. Correct? Okay. So very simple. Now using n bits. For n bits, what will be the answer? The same question for n bits. So what is the minimum you can create and what is the maximum you can create? For the maximum, it will be 0 followed by all ones. Followed by all ones. So the maximum is same. That will be 2 power n minus 1. Okay, this will be the maximum. And what will be the minimum? The minimum will be 1 followed by all zeros. 1 followed by all zeros, because this will give you minus 2 power n minus 1. This is the weight it will give you. So the minimum is minus 2 power n minus 1. This will be the minimum. Minus 2 power n minus 1. This is the minimum. So what is the range? If I ask you what is the range, so the range is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. This will be the range. So tell me, for example, if I ask you for 5 bits, for 4 bits maybe. So tell me for 4 bits, what will be the answer? For 4 bits, the range will be from where to where? Minus 8 to plus 7. Okay. So the range is minus 8 to plus 7. This will be the range. Correct? Did you get it? Please tell me. So let's do the comparison of all the range. Range of all representations. Let's do the comparison. Let's quickly do the comparison. Range of all signed representations, I can say. Maybe all representations we can do. Let's do the comparison. Okay, so I'm going to tell you all using n bits, maybe using 4 bits. Let's do first using 4 bits, then we will do for n bits. So using 4 bits, tell me, these are the representations we have. We have unsigned. Okay, there is unsigned. So we have unsigned representation. If your number is unsigned, and if your number is signed magnitude, here all these 3 categories are signed. Here your number is signed number. If your number is a signed number, then here you have 3 categories: signed magnitude. If your number is represented using signed magnitude, or your number is represented using 1's complement, or your number is represented using 2's complement. So in all these situations, let's do. What is the minimum? Tell me. And what is the maximum? Tell me. What is the minimum? What is the maximum? In unsigned, if your number is unsigned, then minimum will be this and maximum will be this. So minimum will be 0, maximum will be 15. So the range is what? Tell me the range. So range is 0 to 15. This is the range, 0 to 15. Okay. This is the range. Here I can say range. So tell me, what is the minimum in sign magnitude? What is the minimum? Minimum will be 1 followed by all ones. 1 followed by all ones. And here 0 followed by all ones. So this will be the minimum. So minimum will be minus 7 and maximum will be plus 7. So the range is minus 7 to plus 7. This is the range. In 1's complement, what is the minimum? The minimum will be 1 followed by all zeros. 1 followed by all zeros, and maximum will be 0 followed by all ones. So this will be the minimum. This is minus 7 and this will be maximum. This is plus 7. So the range will be minus 7 to plus 7. And in 2's complement, what is the minimum? The minimum will be 1 followed by all 0, and the maximum will be 0 followed by all ones. So this will be minus 8 and this will be plus 7. So range will be minus 8 to plus 7. This will be the range. Correct? Is this clear? The same thing you can do for n bits. If I ask you for n bits, then what will be the answer? Let's check it out. For n bits, if you have n bits, then what will be the range and what will be that? For n bits, let's find it out. So it is very simple. If you have n bits, then in unsigned, the minimum will be all zeros and the maximum will be all ones. So the range will be 0 to 2 power n minus 1. 0 to 2 power n minus 1. This will be the range. Okay, 0 to 2 power n minus 1. And what is the minimum in sign magnitude? This will be 1 followed by all ones. Here 0 followed by all ones. So the range will be minus 2 power n minus 1 to 2. And this is the same for both of them. You can notice this is the same for both of them. So let me write like this. You can notice this is the same for both of them. For 2's complement also, sorry, for 1's complement also, and for sign magnitude also, this is the range for both of them. 1's complement and sign magnitude, they have this same range. But remember, see, the range is same. Please understand this point. The range is same, but you can notice here this will give you the minimum, and here this will give you the minimum. So please understand this. Okay, here this will give you the minimum. In this situation, this will give you the minimum. Okay, in this situation, this will give you the minimum. So this is the difference. Okay, so the range is same, but the minimum number, you can notice they are giving you different representation you have for minimum number, for the minimum, and for other numbers they have different representations. And in 2's complement, this will give you the minimum. Okay, this is going to give you minimum and this is going to give you maximum. So the range will be minus of 2 power n minus 1 to plus of 2 power n minus 1 minus 1. So this is the complete comparison. I hope this concept is clear. Let me know. Anyone has any doubt in this?